Hello, this is Mrs. Huntley. This is Module 4, Lesson 14, Graph of a Linear Equation, Horizontal and Vertical Lines. You should be on page 132 of your module. And I just wanted you to notice that I'm going to be color coding some of my answers. So if you would like to also color code, you're going to get 4 colors before you start to take notes. You might also want to grab some scratch paper, some extra paper to work out the problems because you have very little space in your workbook to be working things out, and they don't give you a whole lot of space here. They give you too much space in some areas and not enough in others. So those are the things I wanted to say before we get going. And now we're going to get going. Your essential question for this lesson is, what do the equations for vertical and horizontal lines look like? So we have some exercises. Let's just work through the exercises and we'll unpack what a vertical line is, what a horizontal line is as we're working through the lessons. So on your own, exercises. Find at least 4 solutions to graph the linear equation 1x plus 2y equals 5. Now you'll notice they don't give us a table or anything to set up. So what I would suggest is, in order to keep organized, you set up a T-chart, and you can label your T-chart with your X and your Y. And then you're going to record your X values on the left side, your Y values on the other side. So you're using a table, you're just not doing like the, you're not having the center section for doing your work and having the X and the Y on the opposite sides of the table. And that will just help you to stay a little bit more organized. So for this first equation, I'm going to fix values for Y and solve for x because my y has a coefficient that is not equal to 1. So I'm actually going to make my pen a little bit thinner so that you can see my work. And so I've got 1x plus 2y equals 5. I'm going to set y equal to 0 to start. So 1x plus 2 times 0 equals 5. And 2 times 0 is 0, so x, or 1x, is going to equal 5. So I'm going to go ahead and graph that right away. X is 5, so I'm going to come to 5 on the x-axis, and I don't go up or down at all. And that's my point that starts there. And this is where I'm going to change colors. Just because I don't have the table to keep me organized, I want you to see the different colors. So the next thing I'm going to do is set y equal to 1. And put it into my equation. So x plus 2 times 1 equals 5. Subtract 2, and x is going to equal 3. So x is 3, y is 1, and there's my point right there. And next I'm going to set x or y equal to 2. So and 2 times 2 is 4. So I'm going to subtract 4 from both sides, and x is going to equal 1. Okay. And last, I'm going to set y equal to 3. I'm sorry, that should be a, I just wrote this incorrectly, so let me fix that. So I go to -1 and then up 3. 1, 2, 3. And there's my point for that one. So again, I wanted to color code my points and my work so you saw what matched up with what, being that we don't have a table to keep us organized. So the next one, find at least 4 solutions to graph the linear equation 1x plus y, or plus 0y equals 5. So I'm going to do the same thing here. I'm going to have my T-chart with my x and my y variables. And because y, again, has a non-1 coefficient, I'm going to fix my y's. So I'm going to start with 0. 1x, or just x. 0 times 0 equals 5. And so that's just going to be x equals 5. So x equals 5 right there. It's the same as up top. Let's see, if y equals 1, zero times 1 is going to be 0, so x is going to equal 5 again. And 2. 0 times 2 is 0, so x is going to equal 5 again. And next I'm going to do black, and that's 3. So x plus 0 times 3 equals 5. So x is going to equal 5 again. So you'll notice, regardless of the value that we chose for our y, our x value always equaled 5 when our y was being multiplied by 0. So what's different about the equations in exercise 1 and exercise 2? In exercise 1, both the x and the y values were changing. Depending on what the y value was, we got a different value for our x's. In the second equation, regardless of what our y value was, our x always stayed at 5. So as I said, in the first equation, the x value and the y value changed. In the second equation, the x value always equaled 5. Okay? So let's discuss this. We have our standard form here. That's what ax plus by equals c. That's called standard form. And we've talked about that at some length. So they're saying where a, b, and c are constants, and a equals 1 and b equals 0, and they forgot to write anything that c equaled into your book. So I'm going to say c equals 2. So what that means is we're going to substitute those values in for the variables. So instead of ax, we're going to say 1x, or just x. Instead of b, we're going to write 0, y equals 2. Now we could say c here, but I find that it's a lot easier understanding a concept when you have a number in it, and you can actually solve things with that number. So again, I'm going to make a t-chart over here, and we do have a little bit of workspace. So my x values, my y values. So I'm gonna again set y, because y has a coefficient that's not equal to 1. So I'm going to say y is equal to 0. What is x? So x plus 0 times 0 equals 2. That's going to be x equals 2. When y equals 1, x plus 0 times 1 equals 2. So x is going to equal 2 again. Again, we have a situation where regardless of what I plug in for y, my x is going to equal 2. So when I go to graph this, I'm going to be at where x equals 2, and any value up and down here, regardless, again, of what I put in for my x, or of my y, my x is going to always equal 2. Now I can connect these up with a solid line, and we learned in our last lesson that any solution along that line is going to work in our equation, and it goes on to infinity in both directions. Okay, so let's talk about the theorem, or the rule here. The graph of x equals c is a vertical line at the point of c on the x-axis. What does that mean? C is a constant, or a known number. In this example, our constant is 2. So we come on the x-axis, put a dot where 2 is, and we draw a vertical line through it. And that's how we know a vertical line is an up and down line, and x equals, there is no y value given. That's because y equals 0 and it dropped out of the equation. So it's going to be a vertical line. Regardless of what our y value is, x is always going to be 0 here. So let's take a look at some exercises, and these are on your own exercise. Graph the linear equation of x equals -2. So I'm going to have you pause the video, find where x equals -2, and then draw your vertical line through it, unpause the video, and check your work. Okay, x equals -2 right here. I'm going to draw my vertical line. And all along that line, that's going to be x equals -2. Go ahead and do number 5. X equals 3. Pause the video. Okay, x equals 3 right here. It's going to be a vertical line going through that point on the x-axis and going in both directions to infinity. What will the graph of x equals 0 be? I'm going to just, x is 0 right here. X and 0 are y at the same spot. So if we're keeping with what I've been talking about, we're going to be drawing a vertical line through that point, and it's actually going to be on the y-axis, isn't it? That sounds counterintuitive, but that line is going to be, if I were defining that line with an equation, it would be x equals 0 if it was a vertical line on the y-axis. And I know you're probably thinking, why isn't it y equals 0? Because that's going to be something else. Okay, let's move on to the next equation. This is just like our opening example. So again, I'm going to go back to color coding, and again, we don't have a whole lot of workspace here, and that's kind of why I'm color coding, so you can see what goes with what. So I'm going to start with blue, and I've got 2x plus 1y equals 2, so I'm going to fix my x values. I'm going to start, oh, why am I on red when I have blue clicked? What's happening? There we go, x and y. So I'm going to pick a value for x. I'm going to go with 0 to start. So I've got 2 times 0 plus y equals 2. 2 times 0 is 0, so y is going to equal 2. The next one, I'm going to set x equal to 1. So 2 times 1. 2 times 1 is 2. Subtract 2 from both sides. Oops. And y is going to equal 0. So next I'm going to pick x equals 2. Subtract 4. And y is going to equal -2. Okay, so, oops, I graphed that wrong. I'm sorry. So the green one should be at 1, 0 right here. And now red, I'm coming out to 2 and then down 2. Okay, so now I'm going to go with 3. So 2 times 3 plus y equals 2. 2 times 3 is 6. Subtract 6 from both sides, and y is going to equal -4. Right there. Okay. And at least 4 solutions to graph the linear equation 0x plus 1y equals 2. So I'm going to do the same thing. I'm going to fix x because that has the non-1 coefficient. So 0 times 0, so that's going to be 2. And then I'm going to set x equal to 1. Oops. So y is going to equal 2. And then 3. I'm sorry, 2. So 0 times 2 plus y equals 2. That's going to be 0 plus y, so y equals 2. And then let's go with 3. And then it's going to be 0, so y is going to equal 2. So again, regardless of what my x value was, my y value was going to be equal to 2. So similar to the first exercise, in the first equation, both the x and the y values changed. The graph is taking the shape of a slanted line. In the second equation, the y value was always 2, and we're getting a horizontal line. Now, you can remember horizontal because it's like the horizon. And the horizon is where when you're looking off into the distance. All right, so let's look at the discussion. Again, we have to substitute in some values. And I'm going to say c equals 2 because, again, that was forgotten. So I'm going to draw my t-chart, x and my y values. And if 0 times x plus 1 times y, or just y, equals 2, regardless of what I plug in for my x, my y is always going to be 2, just like it was on the other page. So I'm just going to kind of copy my t-chart from the other page since we're still going with a 2 here. 3, 2. Then if I'm graphing that, I come to y equals 2 right here, and I'm going to draw a horizontal line through that point. And all of those values going in both directions are going to be y equals 2. The graph of y equals c is a horizontal line at the point of c on the y-axis. Again, c is any number. So say y equaled 3. You go up to 3 on the y-axis, or y equals -8. You go down to -8 on the y-axis and draw that horizontal line. So again, let's go ahead with the next problem. These are on your own. Graph the linear equation at y equals -2. I want you to pause the video, plot where you think it's going to be, and then unpause the video to check your work. Okay, -2 is right here. So I'm going to draw a horizontal line through -2. Okay, graph the linear equation of y equals 3. Again, I'd like you to pause the video, plot where you think it is, and then unpause the video to check your work. Okay, on the y-axis, here is a 3. It's going to be a horizontal line through that point. Okay. What will the graph of y equals 0 look like? Again, 0 is right here, so it's going to be on the x-axis. And I know that seems really like backward, but if you can remember that the y is going up and down and you're just plotting the point there, and anytime we know what our y is but we don't know what our x is, it's going to be a horizontal line. Anytime we know what our x is but not our y, it's going to be a vertical line. Well, I kind of just gave you the summary. This is the Eureka Ease, and I know if you copy this down word for word, you're not going to understand it. So I would really like you to put this in your own words. So the graph of x equals some number is a vertical line that passes through the point of that number, comma, 0. So when you see that, you're going to find that it's going to pass through the x-axis and it's going to be a vertical line. The graph of y equals some number is going to be a horizontal line that again is going to be passing through the y-axis at that number, and it's going to be a horizontal line. So that concludes this lesson at exactly 20 minutes. I hope you've had a great night, and I will see you in class tomorrow. Take care.